Okay, well, welcome to everybody, welcome to our second Zoom lecture. For anyone who doesn't know me, I'm Danny Collins, new president of the association. A couple of housekeeping things and just confirmation of the format of our meetings. We'll be going straight to our main speaker, our guest, Nick Howes, without a preliminary state of the night sky. Paul Evans looks after that fairly well on the website and in Stardust. If you haven't paid your membership dues, you won't be getting Stardust, so I would recommend everybody do so. It's a highly polished magazine, thanks to Andy McRae, the editor, and with able assistance from Tony Kempston. With regard to the talk, if you have any questions, use the chat button at the bottom of the screen. Just type your question in there, then I can refer to them at the end of next talk, which is more or less the fairest way to do it. So without any further ado, can we go over to our guest speaker?
Thanks, Danny. Thank you, everyone. Strange, the last time I was giving a talk to your society was at Queen's University in Belfast, which was a really fantastic experience, and got to thank Paul for that one. So tonight's topic, bit of a hot one at the moment, bit of a very hot potato. How do you solve a problem like debris with no reference to Julie Andrews at all? Bit of a pun, but there is a significant and growing issue which everybody is thankfully becoming a little bit more aware of, but as with politics and various other things in this world, it seems to divide people quite significantly down the middle as to what the issue is. So moving on, next slide. What is the problem? Our wonderful friend there, Mr. Musk, he's going to get a bit of a kicking during the course of this talk, but I'm not anti-Musk. What Elon has done with the Falcon 9, Falcon Heavy is nothing short of miraculous. What he's done in terms of transforming spaceflight and capability and the cost savings of that, with obviously partnerships with NASA and various other organizations, has been incredible. And I would expect anyone who's seen the Falcon Heavy twin cores landing in parallel were amazed pretty much in terms of how he managed to do that, being the first vertical landing of a rocket from orbit, and obviously hopefully soon to be joined by Jeff Bezos and various other people. But he kind of, as I said, divides people a lot, especially in the astronomy community. And this is because of, as I said, a growing problem that's been with us since the late 1950s, in effect, since we launched Sputnik, although Sputnik and most of its fairing and stages did come out of low Earth orbit and burn up quite harmlessly on our atmosphere. From around about the early 1960s, the start of the space race with Mercury, Gemini, Apollo, and obviously all of the communication satellites and military and defense satellites that were put up, we have had an increasing effect on low Earth orbit, medium Earth orbit, and geosynchronous orbit. We're not too concerned at this time about deep space, although the plans for the Lunar Gateway and associated paraphernalia that will be needed to support that could be an issue moving forward. But in essence, this is going up to 2015, which gives you a rough example, a rough idea of what we're dealing with. Since 1961, and there are still satellites up from that era, we have managed to put into orbit around about 170 million pieces of debris. Now, that's not satellites, of which there are currently about 3,000 to 3,500 active, inactive satellites in orbit. That's debris. That's pieces that have come off either from fairings, first stages, second stages on things like the Apollo missions, for example. Gloves from Gemini, 480 million pieces, 480,000 pieces of debris in terms of needles, when in the early 1960s America decided to make their own ionosphere, and all sorts of other paraphernalia, as I said, since the early 1960s, creating quite a mess. Now, we're used to the concept of quite a mess. David Attenborough and the Blue Planet series did an incredibly good job of highlighting plastics in the ocean, a significant problem that thankfully we are now getting to grips with, as in we understand it and we are now taking mitigation steps against it. Most of the waste that we see in the oceans actually comes out of about 6 different river systems in the Asia Pacific region. unfortunately, they seem to have very lax regulations in terms of pollutants. You've got companies like Evian and various other large plastic bottle makers, for example, desperately trying to do lots of PR to stop news getting out that a lot of the pollution is being caused by waste from their facilities. There's all sorts of scientific exploration and investigation underway, trying to ascertain where the pollutants are coming from. It's the breakdown as well into microplastics, which are extremely harmful to aquatic sea life. Not only the islands that are floating in the middle of the Pacific and the Atlantic, some of which are almost the size of a county, just basically of plastic debris. Now, the wonderful thing about plastic is we can recycle it, we can capture it, we can mitigate against it, and it's typically moving around at ocean velocities, so a few knots. The problem with space debris is it's not. Space debris is moving at around about 7 to 8 kilometers per second. In low Earth orbit, 17,500 miles per hour. It's just under 5 miles per second. Any of you remember your high school physics will know that K equals half mv squared. And if you've got an inelastic collision between two bodies in orbit, even with a relatively small mass, you've got catastrophic amounts of kinetic energy being generated and potentially destructive energy. I'll demonstrate some images which show that later. So this is a problem that is, as I said, growing, and one that's been researched quite heavily to look at the real impact, pardon the pun, of what's going on up there. So this was an experiment conducted on screen now by the University of Florida a few years ago, where they basically built a satellite around about the size of a fridge. So a typical 50 to 250 kilogram satellite, not your CubeSat size. This is a inverted commas proper size satellite. And what they did in a hypervelocity test chamber, which was surrounded by foam padding, was hit this satellite with a projectile around about the size of a Coke can at 7 kilometers a second. Now, any of you who were at the Reinventing Space conference last year will have seen the talk on this. University of Florida students were still picking the debris out of the foam field, out of the foam surround about a year later. This thing generated upwards of 120,000 pieces of debris, ranging in size from a few like tenths of a millimeter across up to large pieces of wire, pieces of debris. It vaporized the satellite, but you were still getting absolutely huge amounts of debris coming off it. And as I said, that's just an atypical collision. These collisions do happen. They're already happening. Now, I'm a big fan of what Hollywood can do in terms of presenting this problem to the world. I'm not so much of a fan of some of the acting, but I'll just let this one run through. So that was the Hubble being blown to bits there, and the space shuttle. Obviously, the 2013 movie Gravity there, if you've not seen it, it's a good film. The visual effects in it are extremely well done. Some of the orbital dynamics is a little bit iffy. Some of it's actually quite good. But the premise for the movie is extremely frightening and potentially accurate. It demonstrates what's known as the Kessler Syndrome. So around about 40, 50 years ago, a scientist with surname Kessler worked out that the potential for a cascading collision type event was real, and that it was potentially going to happen. Now, what this is in essence a kind of cascading domino effect, where two pieces of debris or two satellites collide in orbit. They create thousands of additional pieces of debris, which then go on to hit other things and other things and other things. And it gets to the point where basically you can't launch anything. That's it. It's kind of game over in terms of space launches. The impact of this is absolutely catastrophic. If you think what we're going through with COVID right now is bad, the issue of the loss of satellite capability and communications in terms of the global economy, in terms of so many different systems that we rely on, will be like biblical. This video kind of demonstrates that quite nicely. So without GPS, we lose our defense capability. And that's the thing, it will be impossible to get it back. If we have a cascading Kessler Syndrome event, as I said, you've got 3,500 satellites, 170 million pieces of debris right now. That's about to increase by a factor of 10. Elon Musk is currently launching at a rate of 60 to 100 satellites per month. The FCC have granted him a license to launch 42,000 satellites. So you've got a tenfold increase just from one constellation company, one management company, of the number of satellites in orbit. Now, whilst he may say that the station keeping, which is kind of how they manage themselves, and the on-orbit artificial intelligence systems are vastly superior to how they were, that's true, he still has a between 5 and 10% failure rate. So at a 5% failure rate with 30,000 satellites, it's 1,500 satellites. So you're basically increasing by 50% the number of dead objects in orbit immediately. And as I said, when they're traveling at those kind of velocities and typically tracked via what's called TLEs, two-line elements. So in essence, what you've got is an orbital pass, and you'll have a radar or an observational detection that will give you an approximate position for the satellite. That will then form what's called the TLE, which is essentially the ephemeris of the satellite, if you want to put it into astronomical terms. So that gives you its kind of sat-nav coordinates. The problem with those is they're out. They're typically TLEs by even one orbit. They can be out by as much as a few kilometers. Now, a few kilometers sounds like a huge distance, but when you're traveling at 8 kilometers per second, it's not a huge distance. And there was a recent near miss between the IRAS satellite, the infrared astronomical satellite, and another object over North America, where the data that came back said that they missed by 17 meters. Because the other thing you don't know is the orientation of the satellite, if it's a dead satellite, if it's got long extendable boom arms, if it's got solar arrays, if there's any degradation on the panels, which essentially means that some of them could be falling off or bits could be coming off already. You don't know that, because even with Space Fence, which is the most advanced tracking system on the planet at the moment, you have between 5 and 10 centimeter resolution tracking. So anything smaller than that, you haven't got a hope of even finding it. Now, going back to the kind of scale of the problem, this is a more up-to-date image of literally what we're dealing with. And the distances, you look at some of the distances, and it is over-exaggerated on this scale. It looks far worse than it is on this scale, but it is far worse than it is. In low Earth orbit, as I said, you've got tens of thousands of objects orbiting around. Astronauts dropping tool bags, tools, gloves, even really minute objects. Now, people will say, well, why isn't this happening already? Well, it is, and I'll go on to that in a moment. But this is just an example of what a pea-sized plastic pellet hitting a lump of aluminium at 7 kilometers per second will do to a lump of solid aluminium. If that was to have struck the ISS cupola module, then everyone on the ISS would be dead right now because of explosive depressurization, depending on if it had been detected early enough. Something like that would have torn straight through the Apollo lunar module, straight through the Apollo command module. There's very few spacecraft up there that could have sustained an impact even on that scale. And you only have to look at, there was an incident with a paint fleck that hit the shuttle window some years ago and cracked it. And that was just literally a fleck of paint about the size of a grain of sand. So these collision events are real and significant. Now, you talk to people in the astrodynamics community and companies like Thales Alenia and SciSys and various others, and they say, yeah, but the station keeping and the modeling seems to predict that it's not that bad. Well, it's rubbish. These are companies that have a vested interest in satellites, in launching satellites, in building satellites, in throwing as many of them up as possible, because it's in their commercial vested interest to do so. And when people say, well, computer models say it isn't going to happen and there isn't really a crisis, I'll just bring that to bear. Around about 6 years ago, a chap called Bill Gates said that the next great problem that the Earth is going to face will be a global pandemic, and nobody at a TED talk, and nobody paid much attention to him. We're now reliant on Excel spreadsheets because we're completely woefully unprepared to deal with this, and it's been highlighted now in 2 of the most developed nations on Earth in terms of the United Kingdom and North America have got some of the highest case counts globally. So it's an issue. It's an issue in terms of, do you want to trust computer modeling? Well, frankly, no. Computer modeling will predict one thing, but you only need a few collision events and you've lost everything. There was considerable amounts of work has been done on this by both NASA, University of Southampton. Now, the University of Southampton studies, a lot of text there. I hate death by PowerPoint with text. But the interesting points there are the close calls. So collision avoidance events, right now there are between 13 and 50,000 collision avoidance events a week happening right now. And that's without Starlink and without OneWeb and without Amazon and without everyone else chucking up as much as they can. As in 2009, 19,000 debris pieces over 5 centimeters. As I said, there's now 170 million pieces of debris which are capable of doing damage to an astronaut on EVA. And I think this is one of the key issues that nobody is willing to kind of accept right now, is that for somebody to react to this, and we are a very reactionary species, for somebody to really react to this, somebody's going to have to die. Because a collision between 2 satellites is just 2 pieces of hardware. Nobody really cares about that. When a spacecraft blows up on the pad, or a spacecraft blows up in orbit, or it fails on its mission, yes, the scientists are very upset and the space community may be very upset, but humanity isn't. But look at what happened after Challenger. Challenger basically put an entire nation into mourning and suspended the space shuttle for several years. Columbia put the same nation into mourning again a few years later and killed the entire shuttle program. It was stopped at that point. They said, it's just too risky. And obviously the repair of the Hubble and the completion of the ISS were its last missions, as it were. So people are going to have to die. Now, we've got precedent with this from the Apollo program, where people, in Challenger and obviously Columbia. But in terms of these large-scale deorbiting events, it's not the large-scale ones that we need to worry about. However, they are up there. And we only have to go back to 1979 with Skylab, which, had the shuttle been a few years earlier, it would have been rescued and they could have bumped it into a higher orbit. But Skylab, that was supposed to come down in a controlled, predictive manner. It didn't. The predicted path was over the South Pacific, off the coast of Darwin. The actual path basically strewn loads and loads of pieces all over Australia. And there's other instances with Russian satellites coming out of orbit and depositing nuclear material even. And there's several kilograms worth of nuclear material still in Earth orbit that hasn't come down yet. In terms of what's happening right now, this is the European Space Agency's Mvsat mission. So the Mvsat is basically about the size of a school bus. That is in an uncontrolled, unstable orbit. They're hoping they're going to be able to bring it down with what little control they have left. But right now, that is a sitting duck. And it's the size of a bus. If that was to be hit by a moderate-sized satellite, you'd be looking at several million pieces of debris, adding to the 170 million pieces we've already got up there in low Earth and medium Earth orbit. I say low Earth and medium Earth orbit because the thing is, with a collision at those kind of velocities, the trajectories are completely unpredictable and you can fire objects up into very high orbits. That was demonstrated quite recently by this event. Well, this is in 2009, but also some of the ASAT tests. So this was an event that happened 11 years ago this week, between one of the Iridium satellites, which we all know and love in astronomy because it's one of those mystical things that we can point out and say, look at that, it's going to get really bright in a few seconds. Ooh, isn't that wonderful? And a Russian Cosmos satellite. This was an instant kind of oblique blow collision that happened, and boom. The modeling on this, so this is from AGI Analytic Graphics modeling that demonstrated what was the kind of impact, velocity, and effect of this using hypercode collision simulations. But basically, this generated tens of thousands of pieces of debris. Now, looking at basic orbital dynamics, it's not just the initial collision event, obviously, or the after effects in the relative area of where the collision took place. The biggest problem is that this debris will then orbit the Earth, as you can see here, and spread. And those orbits where that collision event took place are now completely no-go zones for any spacecraft, because there's so much junk still flying around up there, and that's 11 years after the collision. Then we come on to the reckless ASAT tests. So the Chinese, the Americans, and most recently the Indians conducted anti-satellite missile tests, or saber rattling, as we like to call it in the defense sector. This was essentially them saying, look at us, aren't we fantastic? We can launch a missile from the ground and we can knock out a satellite in orbit. And aren't we wonderful, and aren't we brave? Well, no, aren't we reckless is the key thing. And I got into an awful set of arguments with half of the Indian military over this on LinkedIn. where they were accusing me of not knowing what I was talking about. But essentially, we were saying that the modelling we were doing was predicting that this is going to be bad, and it was. So AGI, who are probably the world leaders in this kind of orbital modelling, their STK software is phenomenal. It's used by everyone from NASA, SpaceX, JAXA, etc. Some of the debris pieces went up to over 2,000 kilometre orbits. They're not going to be coming down for about the next 100 to 150 years. 8 times higher than was claimed by the Indian Space Agency and the Indian military. As yet, nothing's been hit that we know of, but this is the problem. With military satellite collisions, you tend not to hear about it. There was an incident a few years ago with Lockheed Martin satellite, $400 million, it just ripped itself apart. There was a video of it doing this, but nobody knew why. And nobody could predict why. It was there one minute, it was traveling happily in its orbit, and next minute it's disintegrated. So it either hit something or a battery exploded maybe on orbit. Who knows? We don't know. And this comes back to, again, the other key problem is that not only will we not be able to launch things and we're going to lose so much, the insurance costs of launching are going to go through the roof as well. And at the moment, to insure a satellite, most of the third-party liability tops out with the European Space Agency around about 60 million euros. So it's nothing in terms of third-party liability. So if you were to collide with the ISS, you're looking at knocking out a $175 billion space station and potentially killing between 6 and 8 people. Now, there was a lawsuit that wasn't well documented or isn't very well known against NASA after the Challenger incident, where a fishing vessel was struck by parts of the space shuttle. And the guy concerned, his family basically sued NASA, and it was all kind of hushed up. But this is the kind of thing that if you've got celebrities in the next few years going up on suborbital or even orbital flights with the likes of Virgin Galactic and Sierra Nevada and various other companies and Bigelow, and one of these people gets injured or killed on orbit, you're going to see lawsuits the like of which you've never seen before. And the insurance costs, the only people I've ever seen happy about this debris potential issue are insurance people who are literally rubbing their hands together in glee, thinking, yeah, we're going to have a field day with this. The insurance costs are going to go skyrocketing. So what is the answer? What's the solution to this problem? Well, as I said, with plastic in the ocean, we can mitigate against this. There are, ways with vessels of scooping this up, turning it into reusable materials, potentially with some of the plastics. So we can solve that problem. Climate change is a problem we can solve. You only have to look at what's happened since the pandemic started with the reduction in flights, the reduction in standard travel on the roads, and the reduction in emissions and what we're seeing. We're probably too late to do something major, but what's happened has helped. With this space debris problem, at the rate we're going, there won't be an answer. We will become a planetary species unable to get off our planet because we won't be able to find anywhere to launch through. Potentially, who knows, 5 years, 10 years, 50 years, it's going to happen. It's not when, it's not if, it's when. So what is the answer? Well, there's lots and lots of companies working on different solutions. This to me is the most stupid of all of them. This is SSTL Airbus, sorry, satellites, part of a division of Airbus, who are one of the big players in the space sector, with their remove debris harpoon system. Now, the idea of putting a harpoon on a spacecraft and firing it at another spacecraft when you've got an indeterminate orbital dynamics situation and you've got potentially tumbling spacecraft, and if you miss, you could either put it into a worse tumble or worse than that, hit pieces and knock pieces off it. On a 1-to-1 ratio, I think is just mind-bogglingly stupid, and I'm not alone in thinking this in the space engineering domain. There's lots and lots of us think that it was a really, really stupid idea. It was a great example of look at what we can do, but why would we want to do it? And the other issue with this is it's a 1-to-1 ratio. So essentially, to get one piece of debris out of orbit, you're going to have to send up another satellite, which in itself could become debris and could explode and could fail and could have all sorts of anomalies to bring down one other satellite. So it makes no sense. The other part of the debris kind of solution that SSTL were working on, and this is their kind of promotional video for this, was a net. So again, it's a 1-to-1 ratio unless you put multiple nets on a spacecraft that has enough delta V and enough hydrazine or propellant on board to move between different orbits and capture different things. And then you've got to be really, really accurate in terms of once you've flung the net around it, you've got to understand what the orbit's going to do after you've thrown the net around it. If the orbit's going to change in a way that could potentially put it in the collision path with something else. And then there's the whole issue of, if you're a Russian satellite company and you effectively have someone like SSTL, a NATO alliance member, throwing nets around your thing to pull it down, they don't own it. So could that be instigation of, or almost a declaration of an act of war? There are all sorts of issues associated with this. One of the better solutions is a company called Astroscale. So this is a joint UK-Japanese proposal where they are doing extensive modeling of the orbit. So essentially what they're going to do, again, it's a 1-to-1 ratio spacecraft, unfortunately, although they have this idea of magnetic tethers. So the concept is that they send a spacecraft into orbit, essentially around a smaller tumbling piece of debris, much like Rosetta did around 67P. Extremely complex orbital dynamics, very, very hard to do. Lots and lots of, as you can see there, microthruster movements to get all the mapping. But once they've mapped the satellite and its tumbling characteristics, the idea is that they're going to either latch onto it or send out a small object like a magnetic tether with sufficient delta V and thrust capability to take the debris object out of orbit. If they do the latter, it's quite a good idea in that they can at least get more than one piece. If they do the former, again, it's as silly an idea unless they've got sufficient propellant that they can essentially grab on one object, fire it in a downward direction, in essence, to take it out of orbit, let it burn up harmless in the atmosphere, and then carry on. The other one is Northrop Grumman, a big defense company who've worked on what's called the MEV, which is a maneuvering unit designed to change the orbit of defunct satellites and in essence resurrect some of them. So some satellites, the onboard computers are still perfectly viable. The onboard systems are viable, they just don't have any propellant left. So the MEV was recently deployed and changed the satellite's orbit and basically gave it a new lease of life. So that's another alternative. Or putting objects into graveyard orbits, either heliocentric orbits or high geostationary orbits. But then you're just moving the problem further away. Heliocentric, not so bad. If you chuck it into the sun, great, fantastic. You really are getting rid of it then. But it's a non-optimal solution. Now, this isn't just me saying this, kind of angry guy in the UK. This is a growing problem that is getting more and more traction now in the space science and the space engineering community. You've got things like the MIT Technology Review, which highlighted the problem of literally the scale and number of the objects that are going up there. As just one example. And this is a kind of video that just shows, lots of you probably watch these, the SpaceX launches. And they, like I said, it's fantastic to see the cores coming down, no objection to that whatsoever. It's absolutely wonderful to see. But what you have here is essentially 60 more pieces of, and you can see a piece of debris. Did you see that piece of debris fly off? And another one there. These are pieces of debris just flying off a spacecraft, but they're flying off at 17,500 miles an hour. So not ideal, not really what you want to see. And that was a Starlink deployment. And as I said, at the moment, there are around about, I think, 715. So Elon Musk now has the largest satellite constellation in history already. And the FCC, for whatever reason, and, you know, it could be contractual reasons, it could be all sorts of, you know, I don't want to say nefarious reasons, but there could be. It's much like some of the contracts that are awarded in this country always seem to go to the same large space primes. But the FCC have granted Elon Musk license capability for 42,000 Starlinks. Now, the issue with that is that, as Terry and I have talked about quite a few times on our little radio show, and anyone who points a telescope at the sky will know, they're already causing a problem. Starlink magnitudes on the initial launches made them visible to the naked eye. So lots of people would go outside and look up, and in a way that was kind of nice because it made people look up at the sky, made them appreciate what space was and objects flying over. But that was, you know, 35 or so satellites. Once Musk got the ire of the astronomies and the astronomy community on his back, he decided to deploy the sun shields and reduce the albedo, the reflectivity of the satellites, and drop them now to around about magnitude 8. So it's a case of out of sight, out of mind. As far as the general public is concerned, the problem's gone. It doesn't exist anymore. But anyone with a telescope will know, or with a CCD camera will know, and I've got a average size observatory in my back garden, I can hit magnitude 20 with ease with the CCDs that I've got and the telescopes that I've got. And most of the research grade observatories around the world, I used to work on the Fox telescope, we could hit mag 24 no problem, mag 25. You've got telescopes now that are going to mag 27, mag 28, obviously a logarithmic scale. If you've got 3,500 pieces up there already and they're having to deal with that, you imagine if you increase that by tenfold just with Starlink, and that's just Starlink, then we have to factor in everyone else who's going to be throwing stuff up. So the FCC approved this. There's all sorts of contentious lawsuits because they may in fact be breaking environmental law. As I said, with a between 5 and 10% failure rate on Starlink, you could be looking at anywhere upwards of 1,500 to 4,000 dead and or redundant satellites in orbit. And they say, oh, we've got deorbit capability and we've got this and that. Well, if a satellite dies, you've got nothing. You've got a tumbling piece of metal. That's what you've got. And that Scientific American thing there confirms that the FCC have already granted them, as I said, licenses for 42,000 objects. Now, it's not just, I'm not just Musk bashing here, because this is not just a Musk problem. This is a, well, if I'm doing it, what do you think Xi Jinping and Vladimir Putin are going to do? Are they going to say, oh, look at this fantastic American constellation. I'll have a bit of that. That's fantastic. There, we'll use that. Given the fact that the UK government has just killed Huawei and the US government has killed Huawei, the Chinese and the Russians are going to deploy their own mega constellations, for want of a better term. It's an inappropriate term. Mega constellation is incorrect because it's not a mega number, but they're going to deploy huge constellations. Make no mistake in it. And they're going to be on the same kind of scale because they'll want the same kind of capabilities. They'll want the PNT, the position, navigation, and timing capabilities. They'll want the increased capability for their defense forces. They'll want the increased capability to bring, internet to rural communities. Russia, vast landmass, much bigger than the continental United States in terms of typical landmass, as it were. And then China, you've got the most populous country on the planet. So they're going to want these capabilities, if nothing more than just to say, we can do it as well. So if you've got OneWeb, and the UK government's just spent $450 million buying a defunct, redundant, bankrupt satellite company for a reason that it actually doesn't make sense at all to anyone with a space engineering background, but they'll shoehorn something in, I'm sure they will. But we've got OneWeb, you've got Amazon, you've got Starlink, then you've got whatever Russia do, whatever China do. You could be looking at anywhere upwards of 80 to 100,000 satellites in orbit within the next 20 years. Now, if that's not a collision event waiting to happen, I don't know what is. And as I said, the analogy with plastics in the ocean, nobody cared until Attenborough raised it. It was there, but nobody cared because it wasn't highlighted. So in essence, we need someone like Neil deGrasse Tyson, Brian Cox, somebody really significant in the space community to really start highlighting this. But as I said, our government is ploughing millions into space as the next frontier. The strategic defense review that's just happening at the moment, and some of the initial defense meetings my company are involved in, and it's all space, AI, machine learning. Tanks and the like, they're not a thing anymore. My company helped design the Queen Elizabeth aircraft carrier. It's a £3.5 billion target as far as we're concerned right now, because China are developing hypersonic glide missiles, which can travel at Mach 22 and are steerable and maneuverable. So how do you deal with that? The whole strategic battlefront as it is changing, and rightly so, because space and cybersecurity are a key part of all this. And a cyber threat is a significant threat to any nation. You only have to look at what happened with the NHS last year with the cyber attack that took out so many hospitals. It puts people's lives in danger. So we need to do something about this. But does he care? Does he really care? At the moment, they can talk about altruism, and they can say, well, we're an altruistic intent, and we're going to deliver all these fantastic satellites, which are going to give people in Africa internet. People in Africa want food and water. They don't need high-speed internet right now. I mean, high-speed internet communications is a growing importance, and across the world there is more and more need of it for first responders, for all sorts of different. There's a great post from the Washington State first responders this week saying Starlink made their jobs possible. Yes, but do you need 42,000 of them? That's the big question. And it's all down to money. Musk is making billions of dollars in contracts, etc. His company are growing at a phenomenal rate. And as I said, from a scientific perspective, what he's doing with the Falcons, with Starship, Terry and I regularly talk about the Starship tests, the grain silo tests. That's incredible. I don't want to put 20,000 hippies on Mars. I think that's a really, really bad idea. I'd like to go there first with scientific exploration rather than chucking a load of people up there to pretend to colonize it in the Mars One style. But there's a lot of good in terms of what he's doing, but also he seems to be willfully or blissfully ignorant of the havoc he's causing, not only to astronomy, and it's not just optical astronomy. One of the key elements, I worked on the Square Kilometre Array telescope a few years ago. And that thing's incredible. I mean, the SKA's capabilities of being able to detect an airport radar at 30 light years, and what you've got to do in terms of being able to filter out data from that thing due to radio interference, at the moment is complex enough. But if you've got all of that FCC bandwidth being allocated to all these mega constellations in orbit, then filtering out stuff is going to be increasingly difficult. And from a telescope, from an optical perspective, how are we supposed to detect new comets, new asteroids, potential threats from those objects if we're having to filter out so much junk crossing the sky anyway? And the Wide Field Sky Survey telescopes, which are massive instruments capable of hitting very, very low magnitudes, are going to have a really, really bad time with this. So in essence, it is time to get going back to the Sound of Music theme, it's time to get our thinking caps on. What are we going to do about this? And there's some really good minds around the world thinking of ideas, but it all seems to be on a one-to-one basis of send one satellite up and we're going to bring another one down. And the issue you've got if you were to send up something larger, say you were to send up a large aerogel type array where you had 4 satellites that you could fire almost like an aerogel net in between them, because we know that aerogel's capabilities of stopping something at hypervelocities, to look at the Stardust mission where we're stopping cometary fragments at very high velocities with aerogel, or something like that. Or we've looked at an idea with synthetic hagfish slime, which is a material that expands by 10,000 times its volume when it touches water. So there's ways of creating large debris capture systems, but then you've got the issue of what else are you catching? There could be satellites up there, and there's lots of satellites up there that we're not supposed to know about. There's a really famous Russian satellite called Luch, L-U-C-H, which was totally confidential until CNN told the whole world about it. This satellite is able to move in ways that really shouldn't be possible, but shouldn't be happening, and nefariously sneak up on NATO assets within a few tens of meters in some respects, and essentially suck up as much data as they can from the RF emissions from the satellite. And there's lots of those up there. There's lots of Chinese, Russian, North Korean, whatever satellites in orbit, on orbit, that we're not supposed to know about. They're deliberately there for us not to know about. You only have to look at the X-37B, the mini space shuttle, that the Americans send up regularly and leave up there for 2 years at a time, that nobody's supposed to know about, but every amateur astronomer can tell you exactly where it is because they're just looking at it. We've really got to think this one through. And it's either a case of, okay, do we increase? I mean, one of the arguments is, we just need to increase the cost of launch, or increase, get a pool of money together so that we've got something that enables a neutral company like a United Nations type body to develop systems that can deorbit stuff. Well, that's great, but nobody's willing to pay for it. The costs to launch already, I mean, they've come down significantly in the last 10 to 15 years, but they're still high, relatively high. Even Musk and his reusability, you're still looking at several $1 million per launch to get anything sizable up. And he's making his return, obviously, because he can return 80% of the spacecraft. So the likes of ESA right now are really struggling. Arianespace are really struggling. They're heavily subsidized anyway. They can't afford, to get anything wrong, because the costs to them are astronomical, pardon the pun, compared to anyone else. So it's kind of, what do we do to not only enable us to continue as a spacefaring planet, and enable us to continue with the scientific exploration that we all love. We all love to see New Horizons and Rosetta and Galileo and Cassini and all these spacecraft, doing their jobs. But if we can't launch out for our own our own orbital space, then scientific exploration ends. And that video that demonstrated the catastrophic effect on global communications and mobile phones and the banking system, all of those things will collapse. But then the things that we rely on to tell us that we're messing up our own planet, like Earth observation for global warming, for climate change, all of that will go as well. So it is time for the planet and or hopefully lots and lots of very smart people to collectively get some ideas together. And it needs to be forced through, because as I said, I don't think anyone's going to take any action on this until somebody dies. And it's going to, it's going to be something significant in an orbital collision. It's going to be something hopefully not quite the scale of gravity itself, but something akin to that is going to happen. The ISS, and Terry and I talked about this on our last radio show, had to move only quite recently, because there was a collision threat. And twice in its history and existence, the astronauts have all had to dive into the Soyuz because the threat was so significant to collision that they literally would have had to just jettison and come back to Earth. And that is nearly $200 billion and 130 shuttle flights worth of engineering excellence in orbit that we don't want to lose. If it gets dumped in the Pacific in the mid-2020s, so be it. That'd be a real shame as well. But the last thing we need is something colliding with it. You only have to look at the recent EVAs where they were trying to repair the solar panels. There's holes. You could see the holes from the astronauts' head-up cameras. Things are hitting it already. And if it's smaller than 5 centimeters, they don't even know it's coming. So on that note, I'll hand over to Q&A and say thank you very much for listening. And if anyone's got any questions, feel free.
Oh, thank you, Nick. That was extremely illuminating. Let's see, we have one question from Terry. Do you want to go ahead, Terry?
Yeah, sure. Can you hear me, Nick?
I can, Terry. Yeah, got you clear.
A tour de force, just as I expected. Just one thing, the major meteor showers are obviously not a threat to the Earth itself, but some of the ones that have either very, very high collision speeds or larger than average particles, do they add to the problem by hitting some of the bits of space debris and breaking them up into even smaller bits or even more bits?
Absolutely. I mean, big fan of meteorites as I am. These things, obviously, depending on what orbit they're coming in from, can be traveling at anywhere up to 22 kilometers per second before they hit the upper atmosphere, sometimes higher. If you've got a small meteorite the size of a pebble, again, it can cause a significant amount of damage, knock-on damage. And this could be one of the things that caused that Lockheed Martin incident I was talking about, where the satellite literally tore itself apart. Because the issue that LM and other companies are going to have is that once something like that happens, with insurance, you've got to prove liability. If you can't prove liability, if it's a micrometeorite strike, or if it's a collision event from a 1961 defunct satellite piece, who do you sue? Who do you claim your insurance from? You've got collision insurance, but typically you've got to have liability, and there isn't any. The other one that I didn't mention that Terry's just reminded me of is solar events. So right now the sun's dead. I mean, in terms of sunspot activity, it's almost like a Maunder minimum again. We've had almost no sunspot activity now for quite some time. There was a CME in the last few days that was quite significant. If we were to have a high X-class event with the current proliferation of small satellites, CubeSats in particular, so there's hundreds of CubeSats being thrown up by academics, universities all over. Those things don't have the radiation hardening capabilities to withstand a high X-class flare or a significant CME type event. If that happens, if a Carrington scale event, and don't forget it happened, we're not making this up. The Carrington event happened, and at the time it was only the telegraph system that got affected because that was the only major electrical system on the planet. But you only had to look back at late 80s with what happened with Canada when there was a big X-class event and the electrical grid got taken out. Now roll that forward 40 years, and you've got so many satellites up in orbit, and obviously the big defense satellites have got significant amounts of radiation mitigation. But the smaller ones don't. They're nothing more than glorified Raspberry Pis with a bit of aerospace grade aluminium tucked around them and some Kapton foil. There's not a lot to that. So if you take out with a large flare or a large solar event several thousand satellites in one go, not only are you going to have the knock-on effects of everything that those satellites delivered in terms of telecommunications or data or whatever, you're going to have several thousand dead satellites. And Starlinks are small. They're not big. They are the size of a fridge, kind of size, a small fridge. So a big X-class event with those, and they're going to have a problem. And they can say, well, we've built in radiation shielding. That kind of scale of event is significant, and we haven't seen one in quite some time now. We have been going through a prolonged solar minute. We've got the new solar cycle starting, so maybe it's going to ramp up, but we have had a prolonged minima of solar activity. So yeah, between micrometeorites, as I said, the problem as well is that we can't track the stuff that we should be looking out for, like Chelyabinsk. We missed that, and that was 17 meters wide. Your 50 to 100 meter wide category of comet, asteroid, whatever. I mean, I've always said comets are the bigger threat. Asteroids aren't the biggest threat. Comets are the biggest threat because you can't predict them. And you only see them when they cross the ice line at Jupiter-Saturn orbit. And at that point, Hale-Bopp was 35 kilometers wide, nucleus. Had that hit the Earth, we wouldn't be here. There'd be nothing alive. Everything would be dead. So the ability to track that is important. And they'll say, oh, statistics say we're not going to get hit. It's only once in a generation. Well, there's been 3 in Russia in the last 120 years. Between Tunguska and Sakhalin and Chelyabinsk, you've had 3 quite significant strikes over Russia in the last 112 years. So it's a problem. It's a big problem, and I agree, Terry. Yeah, micrometeorites. If you've got 3,000 objects up there, you've got a whatever percentage risk of a collision event. If you've got 100,000 objects up there, you've got a much higher percentage of collision. And you only need one micrometeorite strike to take out one big satellite that goes into a tumble that spreads itself into all sorts of orbits. Game over.
Yeah. One of the other lectures we had not so long ago was about space law. And I'm wondering, is there any requirement or any consideration being given to requiring people that put stuff into space to post in advance as sort of a surety, which would cover any damage that was done if they're responsible for damaging another satellite, or even worse, an injury in the ISS?
Well, that's part of the third-party liability. There's companies like Alden Legal, for example, who are advising the UK Space Agency right now on this, because the UK Space Agency regulations for launch, obviously everyone's aware that the UK is aiming to be the first European launch site. So it's in some ways great, in some ways bonkers. You've got 5 sites vying for this up in Scotland alone, which is ridiculous because that's almost as many as you've got in the continental United States. You've got Sutherland, you've got Western Isles, you've got Shetland, Prestwick Airport, Campbelltown. It's ridiculous for a nation the size of Scotland, and if they devolve, it's going to become even more ridiculous. Then you've got Cornwall. All of the regulations for that, the document that was published by the UK government for regulatory oversight is 800 pages long. And there are 16 separate agencies involved, from the Maritime and Coast Guard Agency, Marine Scotland, the Environment Agency, Health and Safety Executive, the nuclear fuels industry, defence sector. Everybody's involved because everybody's kind of like, well, if you do this, this is going to happen. This is bad. If you've got a Rocket Lab scale, what we're envisaging is something very similar to what Peter Beck's got in New Zealand with Rocket Labs. So essentially, somewhere like Sutherland is a peat bog. So they're going to essentially turn a SSSI site, which everyone objected to in the first place, into a launch site. Now, if anyone knows anything about peat, when peat dries, it becomes one of the most combustible materials known to man. It burns like a good one. So if you get an event on the ground, I mean, this is all to do with range safety, on the ground that causes an explosion, you could be setting fire to half of the Moyne Peninsula. Then you've got the whole issue of the launch trajectories of these go directly over the oil fields in the North Atlantic and off the coast of northern Scotland, and then directly over the Faroe Isles, apart from one of the launch sites, but most of them go over that in terms of trajectory. So China have proved quite recently that launches are still complex, and they hit a house with one of their first stages. Now, the third-party liability in China, I'd imagine, would be, okay, we've hit your house. Well, sorry, we'll build you a new house, and here's $50,000 dong or whatever they trade in China these days. Here's some turtles, and away you go. That's not going to happen over here. It's going to be a lot more significant. So the third-party liability, as I said, it's currently topping out about 60 million euros. Now, that may sound like a lot, but if you have a collision event that causes significant amounts of either structural damage to something of importance, like an oil rig, for example, or you hit people, you only have to look at things like the MH317 aircraft collision and what's happening with Boeing right now. They're being sued out of existence almost by people who, with the 737 MAX had issues, obviously, with that. It's going to be a big problem. The insurance side is going to be a big problem. Can you mitigate against that? Well, as I said, Terry, once it's up there, if you have a fragmentation event or you can't demonstrably prove that it was your satellite that caused that problem, then what are you going to do? And you could then say, okay, well, my satellite worked fine for its 5-year expected life. Currently, it's 25 years is the deorbit kind of regulation, which is ridiculous. I mean, 25 years is just insane. You only have to look at where we were at 25 years ago to where we are now to think of where we're going to be in 25 years. So to say you got a 25-year life expectancy on a satellite, it's just silly. It really is silly. However, if you shorten that down too much, then people are going to say, well, there's no point in me putting a satellite up because in 5 years' time, I'm going to have to put another one up. It's going to cost me X amount. And you only have to look at the Hubble, and they'd say, well, why are you allowing the Hubble to live more than 25 years? The Hubble's been up there since the early 90s. Why isn't that subject to these regulations? So there's all sorts of legal arguments on that front as well, in terms of where do you draw the line? The answer is it needs law, and the problem with lawyers, no disrespect to any lawyers who may be in the listening audience, but the lawyers love what they do because of the potential financial gains from it, and upholding the law, which is fine. That's what lawyers are paid to do, uphold the law. And if the law says X, Y, Z, then they will do X, Y, Z.
Thanks. This is a question from Andy.
Andy, you want to go ahead? Andy?
No microphone. I could read it out for him. I have it on the screen here.
Yeah, sure.
Andy says, Nick, great review of the subject. You mentioned the sensitivities around cleanup using nets, etc., and the problems of paying for this. Surely recognizing the problems because everyone is affected equally, can international treaties and contracts not be put in place to tackle this, say, using the United Nations or similar?
Yeah, I couldn't agree more, Andy. UN COPIUS, there's all sorts of frameworks in place, but it's whether or not the UN's got the metal and the teeth to dig into this. And then when you're up against, as I said, there are nation states out there who pay lip service to UN treaties, and that's not just China and Russia. That's the United Kingdom are currently about to break international law with Brexit. You've got the United States who regularly break or pull away from treaties and international law. So if it's not in their vested interests, you only have to look at what's happening with, oil mining in Alaska and the supposed treaties that are there to protect this. United Nations, if it had the wherewithal to really get to grips with this and had the unilateral backing, probably could do something. But then, if X country says, well, we're not going to do this, and then their neighbours will veto, whatever as well. And however many bodies are on the permanent committee on the UN, including us, you only have to get one or two who say, well, we don't agree with this. And what do you do? So again, it goes back to the legal argument. Yes, we do need the United Nations. We need almost like a United Space Treaty, as it were, because we've got the 1967 nuclear treaty where we can't put arms in space, although the Russians are ignoring that as well right now. They recently deployed a ballistic object, which was clearly designed as an anti-satellite test. It was tracked. It was obvious what they were doing. They had cannons on some of their Salyut spacecraft in the 70s, and I'm not joking. They actually had cannons. You can find out all about this on various websites. There's obviously the Strategic Defense Initiative, the Star Wars thing that Reagan introduced in the 80s. That is potentially going to be resurrected because everybody's seeing now the United States now have a space force. They're seeing a space as being the next big frontier in terms of the battleground, and it is. Because if you knocked out GPS, or you knocked out SATCOMs, or you knocked out the capability to communicate with ships, once a ship's gone more than 15 miles off the coast of wherever, it's, in effect, it's back to map reading days and looking at the stars. You know, we've got quantum navigation technologies and quantum compasses, etc., coming in now. That's going to change things. That'll be great, and it'll reduce the reliance on GPS. But right now, we've got a group of aging satellites which are effectively keeping most of the world's defense service between Baidu, I've forgotten the name of the Russian one, but the Russian, the Chinese, and the American systems, and obviously Galileo, which would have been great had we not pulled out of the EU. So it's in response to Andy and Chris as well. I've seen that question, but essentially, yeah, we do need a unilateral body. It is very worrying. So I'm just reading Chris's question. He said, thank you very much. It's very nice. It's interesting, deeply worrying. It's summarized. There'll probably be no solid action until there's loss of life and the associated bad PR. Yeah, it's true. I mean, that's the reality. You only have, as I said, you look at Challenger. Morton Firecall said that the shuttle was going to blow up. They told NASA it was going to blow up. They explained what was going to happen. They said, do not launch in those low temperatures. And they were ignored. And it was kind of like this. And Musk, in a way, is the worst proponent of this, because his risk aversion is laudable in some respects, because, you know, he blew up Pad 39A. So what? Move on. Carry on. Rebuild it and crack on. And that's great, because it means that we are accelerating as a species into potentially, you know, something like Starship happening, and the Falcon Heavy, you know, being able to go out to Mars, launching a Tesla to Mars. I mean, publicity stunt as it was, it proved the capability of a really groundbreaking spacecraft. But that kind of risk aversion could be the death knell, because will he care? You know, if he's putting people's lives at risk. Obviously, the Dragon capsule, he's done a great job with that as well. It was a fantastic achievement. And one of the things I think that we need to get over as a species as well is, if there's a car crash, we don't stop all cars from driving. If a boat sinks, we don't stop all ships. If a plane crashes, unless you're Boeing and you're lying through your teeth about it, we don't stop all planes. But if a spacecraft blows up, Virgin Galactic were 4 years between the test flight, which sadly killed the co-pilot, and where they are now, or more than that. Challenger was 2 years. Columbia, as I said, killed the entire shuttle program. So, yeah, Apollo 1 was a good example of, right, this happened. What can we learn? How can we move on? Let's honor the guys and do what we said we were going to do, which was go to the moon. And that kind of risk aversion is laudable, but who knows what's going to happen in terms of the PR. The PR is going to be the biggest thing that will impact everyone. You only have to look at the plastic situation. You know, Starbucks, McDonald's, all these big corporations now no longer using plastic straws, for example, because the Greta Thunberg generation have said, well, I'm not going to shop there. I'm not going to go there. I'm not going to do that. So in some respects, it's good. You know, really negative PR does make people, if it hits the bottom line, they'll think about it. If it doesn't, they won't. So there we go. I don't know where Chris is saying he wants to see people in his company. I'm hoping you either work at Thales or Bombardier, Chris. I don't know where you work, but yeah, this is the thing. Northern Ireland has got, this came out at the Reinvented Space Conference, has got such a growing space sector. It's really booming. And Bombardier obviously have got issues with the aerospace. Everyone's got issues in the aerospace domain at the moment because of obviously the cancellation of flights. But there's so much going on. Thales have got fantastic capability over in their Belfast division, and they're building, you know, some incredible stuff. They're working on the Mars sample return mission. They're doing all sorts of amazing things. But yeah, it's going to, I mean, you look at the UK economy, 40,000 jobs are relying on the space sector. They're estimating that the global economy for space is going to be around about 400 billion this year. And most of that is dropping away quite rapidly because of Sky TV and television, telecommunications kind of disappearing and everyone moving to Netflix and streaming services and cable-based services. So that figure is a little bit erroneous, but it is still a massive growth area. I mean, it's growing at 9% still. it's almost COVID agnostic. It's an amazing area to be in. I work in it. My day job is literally this: is looking at these kind of problems in spacecraft engineering, but it's an interesting one.
If I could come in again, I don't want to hog this, but just heard that Ferguson, now I forget his first name, the Boeing guy who was to captain their flight to the ISS, has just pulled out. He cites personal reasons, but I'm just wondering, is he getting a bit worried about the risks when you go up there?
See, Boeing, the issue with Boeing is that they've got an amazing heritage. Most of us have flown 747s or 737s. They know what they're doing. Boeing were instrumental in Apollo. The LVDC, the launch vehicle computer on Apollo. I mean, they've done some remarkable work, but the SLS is so massively overrunning in terms of budget and timescale. Obviously, the issues that they had with their orbital test of their crewed capsule didn't go well, and they weren't even going to do a retest until kind of NASA and public pressure went, well, we're not going to sit in it unless you prove that it works. Right now, I wouldn't get in anything Boeing made, personally. I wouldn't touch it with a barge pole, because at the moment they've got a bunch of bean counters at the top of the tree who are looking at the bottom line. They're not looking at public safety. They're not looking at their engineering excellence. They're looking at how much money they can save or make. And that's the wrong way to approach any engineering task. In any, the great quote from some of the Apollo guys were sitting on, 7 million pounds of rocket fuel built by the lowest possible bidder and the lowest, in terms of contracts. They're sitting on a small nuclear bomb. John Young still managed to keep his heart rate at 75 beats a minute. God knows how he did that. But it's one of those things that we need to escape from this kind of material. And the one positive I'd say that's come out of COVID is people have really taken a step back and thought about what really matters in life. What really does matter in terms of humanity, in terms of what we're doing to the planet, etc. And everyone's saying, "Oh, we've got to get back out and we've got to do this." Yes, and people's jobs and livelihoods are on the line. And there's no escaping that. It's horrible. I'd hate to be in some sectors right now. It must be horrific. But we've got a chance to reset what we do. And I think if we take that chance, we will come out of this better and stronger. To quote Boris Johnson or whatever he said this week, there is a chance that we can really come out of this a lot better as a civilization. So,
Nick, I'll shut up now. I just want to say thanks. That was a superb presentation. Leave it to anybody else that wants to come in.
Nick, if you had to take a wager on a cure for the situation with all the junk floating around up there, where would your instinct take you?
Kessler happening. Astroscale, I like what they're doing, but it's not enough. SSTL, the net is just daft. It's a recovery mechanism if you've got an expensive military satellite that you don't want people getting their hands on. I mean, that's the other thing, is if you've got a redundant satellite up there, you only need the Russians to, attach to it and have some really nice little cameras on it and magnetometers and everything else that they need, and go, oh, that's how you built that. That's what it does. And we'll deorbit it. Or, I mean, thankfully we don't, in some respects, we don't have a space shuttle anymore, because could you imagine the capability of something that could go up there and, almost like the angry alligator, you only live twice James Bond scenario, pluck something out of orbit and kind of bring it down? And that's not a million miles away. That's already happening now in terms of reconnaissance satellites. And as I said, look up the Luch satellite, LUCH. It's really interesting what it's doing, because it shouldn't be doing it. So I think the reality is, unless we come up with something that can selectively almost throw out a hypersonic velocity gel or similar to capture large clumps of this, and in doing so avoid anything else that's coming its way, and that's going to be reliant on the defense companies to say, actually, if you go into this orbit, we've actually got something there that you shouldn't know about, but Please don't please don't net that down for us. I would see that as being the only real potential solution, aside from Kessler happening. Because I just can't see now 170 million pieces of debris, potentially another 42,000 satellites in the next 5 to 10 years, potentially 100,000 in the next 10 to 20 years. I just don't see how we're going to get out of this. I really don't. The sea, plastic, yeah, we can solve. Climate change, I know we can solve if we've got the will and the wherewithal, and people like Trump stop saying it's not real, it's fake news. And it needs somebody. It's really bizarre that, loathsome an individual as he is, what he's done this week with COVID, for example, where, I mean, aside from telling everyone to stop worrying about it, which is ridiculous, but he's demonstrably, from what we can see, if he genuinely did have it, proven via the aggressive techniques that his doctors used, to prove that even somebody of his advanced years and with comorbidities can get through this. Now, if you've got somebody on that kind of scale, and he's not going to do it because the defense contracts and, you know, LM alone are worth the GDP of a small country. If he were to come out and say this is a real problem, then that would be fantastic, but they won't. There was a really funny conference a few years ago that I was involved in, which was looking at the threat of asteroid and cometary impacts. And there were delegates from all over the world at this conference. And the Indian and the Pakistani delegates it was brilliant to watch, because they were saying, well, what would it need for us, the Indian nation, to knock out an object heading towards India just far enough that it hits Pakistan? And that was a genuine scenario that they looked at. And the same with the Pakistan government. They were saying, oh, what would it take for us to knock it? So they just went as far away as India. It's just amazing. People don't... It goes back to the Ed Mitchell quote from Apollo 14 when he said he just wants to grab every politician by the scruff of the neck and take him to the moon and say, look at that, you SOB. That's what we need. We need more politicians to go up into space and say, right, where's your political boundaries? Where's the issue? That's our pale blue dot there. Now what are we going to do? So there you go. Any other questions? Checklist for G550 is about, yeah, I can imagine. I mean, I know, Chris, my company do a lot of work in the naval domain. As I said, we're working with Holland and Wolff at the moment on the Type 31 destroyers, and Ferguson Marine and various other companies. So we do a lot of work in the naval domain, and yeah, the checklists are incredible. I mean, the QEC, if you want to design something complex, that's complex. I mean, the QEC is just insane. It really is. But as I said, right now, 20 years ago when it was conceived, great idea. Right now, sitting target in the middle of the Pacific. It's going to be. Because nothing can stop a Mach 22 hypersonic. Absolutely nothing. You're traveling at 9 kilometers a second almost. So. Any other questions?
You're on mute.
I'm on mute. No?
No, Danny.
Oh. Yeah, fixed. Sorry about that.
Well, if there's any other questions, I'm more than happy to take them. I can sit for hours. Terry knows we talk for hours.
Jerry Davidson had a comment there. Jerry, you still with us? Hello, Jerry. No. But,
yes, I'm here.
Do you want to expand on your comment?
Can you hear me?
Yeah.
Yep.
Loud and clear.
Very, very thought-provoking. Really very thought-provoking. I was aware that debris was presenting problems and had presented problems in the past, but you did raise issues rather like the nuclear situation. You've got superpowers and massive military superpowers with their own plans, their own agenda, and their own technology with satellites, and you wouldn't know what they've got in orbit there. And there's going to be difficulty in them sharing a common plan to try and sort this out. But something that came across, and it's very, very thought-provoking and brilliant talk indeed, was that it's a win-win situation for every country and for all technology in future if the globally, rather like the nuclear situation or environmental situations, we act together. And as a globe, as a world, to solve this is going to take a massive catastrophe, bringing down a lot of satellites or communications or some technological disaster in order that we act. And at times, I think human beings are rather crisis management species. We wait till banks collapse and viruses get out of hand and a whole range of, and then act.
Let's go
So
back,
yeah.
yeah. I mean, COVID's the best example, pretty much, I would say, in human history. You've got GlaxoSmithKline, AstraZeneca, every major drugs company in the world are literally almost ignoring patents and confidentiality clauses, etc., and all working towards a common goal. Because of the scale of the problem. And it's not just how many people have died, it's the scale of the problem and the economics. They've got to do it from an economic perspective. So I think it will take something of that kind of magnitude. But then you look at climate change. Every scientist on Earth, pretty much, apart from people who are funded by the Republican Party or by the big oil giants, is saying climate change is real. It's happening. It's a major problem. You look at Philip Morris in the 70s and the tobacco scandal, like, oh, tobacco doesn't harm you. Well,
yes,
it does. It does. And they got caught out. And this is the thing with, people only react when they're caught out. You look at, what's it called? That movie with Julia Roberts, where she played the lawyer. I've forgotten the name of the film now. But essentially, when companies...
Erin Brockovich.
Erin Brockovich, yeah. They get caught out. They get caught out, and then they have to do something about it. I think with COVID, what it's proved is that science can collaborate, science can get together, and despite the fact that China are being very evasive in terms of letting people in to do independent research and studies, for obvious reasons, and Russia are being very evasive in terms of we've developed a vaccine and we're going to put it out now, but we're not going to tell anyone about it. That needs to stop. And that will only stop when we get rid of leadership. You look at what's happening in New Zealand, and that to me was good leadership in terms of crisis management. Obviously, they've got spike again, and things are not perfect still. But in terms of crisis management, there needs to be a real division and separation between politics and science. That's the first key. Because if you can let scientists collaborate and work together, you look at the ISS. The ISS is a great example of collaboration. The Russians are up there.
Yes.
But, Russia are a sworn enemy when it comes to, what happened in Salisbury with Novichok and Navalny quite recently. But they're still on the ISS. So we're still collaborating. America have got a major issue with China right now, and they won't let them go near anything. So what are China doing? They're building their own space station. They're doing their own space race. They're doing their own Mercury, Gemini, Apollo type program. We need to separate that. If we can separate that, I think we can solve any problem. We can solve a climate change problem. And as you said, it's a win-win for everybody, but then so is climate change. So would be, developing new fuel systems for cars that don't rely on lithium. Everyone's going, oh, EVs are the future. Great. What happens when the lithium runs out? And the open cast mining and the mining that's going to be required to extract all the lithium for the batteries on these electric vehicles. There's all sorts of problems that are looming, and the oil companies are desperately fighting right now to stop everyone moving away from their cars, because the oil price is collapsing anyway due to the lack of transport and aviation. And it's this disassociation from political and commercial gain for science. Science needs to be about science. It always has needed to be about science. And when we do great science, either, unilaterally or multilaterally, you look at Apollo, greatest technical scientific achievement in human history was the Apollo space program, because America chucked so much money at it. And it was geopolitical. Don't get me wrong, it was a space race against the Russians to prove, they could beat the Russians. But the scientific return from that, in terms of the computing that we've got, the Apollo guidance computer revolutionized computer science as we know it. We're still getting scientific information from the Apollo moon rocks 50 years on. So when science does something good, it really does something good. Yeah. And, heart transplants, there's so many things, medicines, vaccines, etc. There's so many things that we need to collaborate. And it is, you're absolutely right, it's a win-win situation, and it will only be brought about by, it's like climate change. When the Maldives disappears and those wildfires in California get to the extent that they're killing hundreds of people and destroying billions of pounds worth of property every year, and the unequivocal evidence is there right now that it's happening, then people may act. But the problem with climate change is it's the frog in the saucepan syndrome. You're turning up the heat. It is.
Yeah.
You're turning up the heat gradually. COVID was, there's a boiling pan and we're going to chuck the frog straight in. When Kessler happens, it will be within a matter of days. 90 minutes per orbit. It'll be literally within a matter of days. So, yeah, it's going to need it.
Thank you.
No, cheers. Thank you.
It doesn't appear to be any more questions unless anybody wants to jump in. No. Well, we could just thank Nick once again for a fascinating talk. It'll be interesting to track developments in the near future.
It's a bit sobering in these difficult times, but
True. As I say, thanks again. It was a fascinating talk. Actually, you've just put me in mind of a book I read recently by Jim Al-Khalili, theoretical physicist, author, broadcaster, commentator. It turns out he's not a bad novelist as well. A book called Sunfall, which is postulating that the Earth is losing its magnetic field. In doing so, it's creating a lot of the similar problems, losing satellites, etc., aircraft falling out of the sky. So I thoroughly recommend that to anybody.
There was a movie The Day After Tomorrow with the whole, and The Core. They're equally appalling or good movies depending on what you think of them. But it's interesting that science fiction sometimes really highlights the problem. You only have to look at Deep Impact and Armageddon. After Shoemaker Levy 9 hit Jupiter, Hollywood got $100 million to make two films, one really good film in Deep Impact, one truly dreadful film in Armageddon, but lots of fun. But it made people aware of that as a problem, and it eventually knocked on, and the budgets are better now in terms of near-Earth object detection. There's a movie coming out quite soon called Greenland, which hopefully will do the same kind of thing. It will be almost like the Deep Impact for the 2020s, as it were. But it's like science fiction with Apollo 13. I know Cy Lieber got really quite well, quite a few of the Apollo controllers. Cy got a career out of that film because nobody knew who he was after the early 70s. And, he was brought front and center again. And it's one of those things that it's bizarre that space conferences, if you put Tom Hanks at a booth, you'd have a queue a mile long. If you put Jim Lovell at a booth, you'd have a couple of dozen people. So science fiction films really can bring a problem to the masses, as it were. And that's the thing, we're all space nerds, for want of a better term. So we all love this stuff and we're interested in it. But the average person in the street, you go up to them and you say, right, who was the first person on the moon? Neil Armstrong. Right, who was the third person on the moon? Or who was the first person on the shuttle? Or they don't know. Space to them is like, it's a rich man's playground. It's Elon Musk and a rich man's playground. So the more sci-fi movies that are good, that bring about this kind of way of thinking with pandemics. Outbreak was a great film a few years ago, Dustin Hoffman, where it was an Ebola type virus that got its way into America, and everyone was like, "Oh, it was a great film," and then moved on. Well, what happens if that really does happen? Oh, look, it's really happened.
Contagion, that was another one.
Yeah, Contagion. Yeah, was another one. Yeah. So, yeah, the art, and then the government's cutting the arts funding. So, hey ho. Who knows? Anyway.
Well, if there's no other questions, a final note of